Hey, you still got a 93. Wow. That was so good. Okay, let's take a look here. Chapter 3 is all about functions. There's not quite as long as chapter 2. A couple of sections take a few days on that. And then we also have to jump into do one section from chapter 1. When they restructured the book, they moved a section from chapter 3 to chapter 1. We still got to cover it though. All right, standard form. Your book calls it standard form. Some books call it vertex form. And then, depending on what you're looking at, some people refer to this, ax squared plus bx plus c, that's a quadratic, as standard form. So just got to make sure you read, the directions. It's called vertex form, referred to as vertex form, because when it's written like this, your vertex, you can just pull out of the equation. So right here, this h and this k will be your vertex. Axis of symmetry cuts it in half. It's an equation. Don't just write a number. Axis of symmetry is not 2. It's not 3. It's x equals 2. It's x equals 3. Now, one thing about this in this form, I also think about it as in transformation form. Because if you look at it, you can tell which way it shifts. So if you look at that equation, which is the same one on yours, right? What does the plus 4 do? Left 4. What does the 2 do? Vertical stretch. Minus 3 moves it down 3. So I'm going to graph using transformations that function. Now, what function is the parent function? It is x squared, which would be negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. So now we're just going to go through the process here. Take your vertex, especially with a parabola. It's easy. Just start with the vertex. Move that first. So I'm going to go left 4. That, since it's on the x-axis, when you stretch it, it doesn't move. And then I go down 3. So I'm going to end up at negative 4, negative 3. And then I take negative 1, 1, and I go 1, 2, 3, 4 left. This time I stretch it up to positive 2. Then I go down 1, 2, 3. It's like I end up at negative 5, negative 1. Negative 2, 4, go 1, 2, 3, 4 left. It'll stretch up to positive 8. And then when I go down 3, it'll go down to 7, 6, 5. And then move your other 2 points. So you move them left 4, stretch them, down 3. Left 4, stretch it, 2, down 3. And so I go 1, 2, 3, 4, stretch up to 2, 1, 2, 3, and then 1, 2, 3, 4, up to 8 to 5. Oops, I kind of missed that. Axis of symmetry. Okay, cuts it in half. And it is a line. Okay, it is a line there. So this case here, my axis of symmetry is x equals negative 4. And my vertex is -4, -3. It's like circles with the what's in the parentheses. Because technically how it's written, it's always x minus whatever that h is. And if your h is negative, it becomes a plus. If h is positive, it says x minus that. So you would flip that sign. Now the second one, the k value, is going to be positive or negative based upon whatever it is in the equation. Right. For that first one, it just says identify the vertex. You got the equation in front of you? Okay. In this case here, Aiden, what's the vertex? What do you think?
-3, 8.
Positive 3, 8. Do the opposite of that sign. Okay. So make it positive 3, 8 vertex. You should be able to give me a lot of information from that. What way is this one going to open, up or down? You know, doesn't ask us. Okay. Justin, what do you think, up or down?
Down.
It's going to open down. I know it has a vertex at 3, 8. So at least gives me an idea right there. You know, a good idea what it's going to look like. So there's my vertex, 3, 8. All right, that second one. X squared plus 4x minus 5. All right. Carter, give me that vertex. Is it a lot harder? Yes.
Good.
Can you just look at it and give me the vertex?
No.
No, the last one's a lot easier. You just looked at it and gave me the vertex. Marissa, what do I got to do? You're like, that's what I'm supposed to do, right?
Yeah.
That's my job. All right. We have to make it look like this. Okay? So we gotta put it in that form. How do we do that? Just like we did with circles, we got to complete the square. Okay, so we're going to do that. Slightly different, okay, with where we put that extra number. So here's what I'm going to do. So f of x equals. Now, when we complete the square, we're really only concerned with that x squared plus 4x. We'll deal with that minus 5 later. So I'm going to start here with x squared plus 4x plus, and we'll put a blank here. Now with circles, we move the constant to the other side, but that was because in circles, it always equaled r squared. It always equaled a constant. Here, we just want to keep it as f of x equals. I don't want to put something else on the other side. So I'm going to leave this minus 5 here, but I still have to balance this side, and I'll explain that in a second with something else. We'll go through your normal completing the square. Take half of 4. 2. Square that, which is 4. Now, whatever I put in here, I got to counter it over there. So basically, I add in a value of 0. So if this is a 4, what do you think I have to put in over there? -4. So really, in the end, have I changed it at all? If I would simplify this, it still simplifies back to this, right? So I put in a 4, I put in a -4, that really washes out to 0. But it allows me to put it in the form I needed. Well, what does x squared plus 4x plus 4 factor into? That factors into x plus 2 quantity squared. Add those other two together, or subtract them, or whatever it tells you to do. -5 plus -4 gives me -9. All right, Carter, now tell me the vertex.
Is it -2, -9?
-2, -9. Once you got in this form, you're like, oh yeah, that's easy. Vertex is -2, -9. Axis of symmetry. Just so that I cover it. What would you write down for axis of symmetry? Adam?
Axis of symmetry would be x equals -2.
Good. X equals -2. You gotta make sure you put that x with there. That would be cut in half. All right, so once we got it in this format, this vertex form or standard form, -2, 9. No problems. Okay. The third one. All right, very similar to that last one. It's not in the nice form we like it. Add another little twist to it is there's a number in front of the x squared. With circles, you remember what we did with that? We divided by 3. Don't do that here because you divide by 3, you actually have to divide that g of x by 3. It just gums it all up. Okay. So if you do have a constant in front, just taking a look at the first two, you're going to factor it out. You're going to factor it out. So g of x equals 3 times x squared plus 4x. And then this is where we'll complete the square inside the parentheses. I still have this minus 7, and I'm going to have to counter whatever I add to this. Okay, counter that. All right, it happens to be the same, daggone it, but what's going to be that number that goes in there? Half of 4 is 2, 2 squared is 4. All right, now, what goes with my second one? And it's not negative 4. Maddie.
Positive.
It's not positive 4.
Oh, wait.
Negative 12. Okay, where'd that come from? Because this 4 is affected by that 3. Okay, it's inside that quantity. 3 is multiplying the 4, so you have to account for that. So if you would distribute this, combine like terms, you'd end up back to where we were. But you got to make that a minus 12. Okay, because of that 3. So here's what we got. 3x plus 2 quantity squared minus 19. That's my g of x. Lizzie, what's my vertex going to be?
Negative 2, negative 19.
-2, -19. Okay, so there we are there. So if it's in that standard form, that vertex form, pull it out. If it's not, we got to do a little completing the square, keeping everything on one side. Okay, and then we write that. All right, find the standard form of the quadratic function whose graph has a vertex of 1, -5 and passes through the point 3, 7. All right, if you see standard form for our book, you got to think, our f of x equals a times x minus h squared plus k. Okay, but that's what it's saying. Put it in that form. We know the vertex. 1 will go where h is, -5 will go where k is. So I can make this a times x minus 1 squared. K becomes -5. Well, the only thing I don't know is a. So use that point to figure out a. Substitute it in. 3 will go in for x, and then 7 will go in for f of x. So I get 7 for f of x. I don't know what a is. X is 3. Here's one thing you've got to be careful of. Because the way it's written, that a is in front. Well, 3 minus 1 is 2. 2 squared is 4. Don't take 4 minus 5. That 4 really goes with the a. So we just make that 4a minus 5. Just be careful with that. I'm just going to never write a4. Just use the commutative property to make it 4a. Now you can solve it. Add 5. Add 5. 12 equals 4a. A equals 3. So my equation, f of x equals 3, x minus 1 squared minus 5. Okay. Now, I'm going to go to the back. You're fine. If it's written in that standard form, you can just pull out the vertex. Okay, it's nice and easy. Okay, and if it's not, you convert it. Well, we don't always want to do that. Okay, it's not always the best thing to do. Remember, if it was in this format before, if it was in that f of x equals ax squared plus bx plus c form, there's another way to find the vertex. And to start, you use this little formula, h equals negative b over 2a. That will tell you the x coordinate. Then you got to find k, but at least that gives you the h value. So I don't necessarily have to convert it every time. We can use that form. All right, and I'm going to do that for this one here. And I also added a couple things here, but they also have to do with the vertex. Okay. So for g of x, that happens to be the same equation we did earlier on the front. But I have different questions. A, find the maximum or minimum. Well, first of all, which one does it have? Does it have a max or min? Matthew?
Minimum,
Why do you say minimum?
because it opens upwards.
Good. It's going to open up, so it's going to have a minimum. We need to find that point right there. Now, hopefully you already made the connection. You know we already have that point, but I'm going to go through it this other way. I'm not going to do completing the square. I'm going to take g of x equals 3x squared plus 12x minus 7. And I'm going to use the h equals negative b over 2a. Just like your quadratic formula, you have a is the number of the x squared, b is the number of the x, c is your constant. So that becomes negative 12 over 2 times 3. And what do we end up with? Negative 2. That is the x coordinate of the vertex. How do I find the y coordinate of the vertex? Plug negative 2 in for x. So find g of negative 2. Go ahead and do that. Anthony, let me know what you get.
Negative 19.
Negative 19, he says. All right, I agree with that. That means my vertex right here is negative 2, negative 19, which should match up what we got on the front. All right, how do I answer the question? What's the minimum value? Okay, Dakota, what would the minimum value be? Of f of x.
Would it be negative 19?
It would be negative 19. So the minimum value is negative 19. Now you might see it written as the minimum value is negative 19 at x equals negative 2. Just depends on how it's worded. But the minimum value is negative 19. All right, what's the range? What's the range? Matthew, you think?
Close brackets, negative 19 to infinity.
Yep. You shouldn't have to do any work because you're looking at this. The y values, the lowest y value is negative 19. And it goes up, so it has to go all the way to infinity. Okay. So you should be able to just take your vertex and tell me the range. Okay, you should be able to do that for any problem once you know that. All right, let's go through this one and try to explain how we're going to use the vertex to solve this. Our teacher knows that for a price of $20 per student, she can enroll 40 students. However, for each decrease of $2 in price, she can expect 10 more students. What price will maximize her revenue? All right, don't write anything down here, but just make sure you understand, first of all, what's going on. So the revenue, I'll call R, is normally going to be 20 times 40, which is what? 800. So what happens if she decreases her price by $2? What does the price go to? Goes to 18. What does the number of students go to? 50. What's 18 times 50?
900.
He says 900. So would it be smart for her to decrease the price if she wants to make money? Which you're all about money, right? Yeah. Now, what if you decrease the price of your tests? Then you get more people buying them.
Probably.
All right. Now there's a point though where that doesn't become advantageous. Okay. So if you keep decreasing the price, eventually it only goes up so far, then it goes back down. We got to find where that happens. We want to come up with an equation to represent this. How can I come up with an equation? Well, hold on. I'll just write, first of all, revenue will equal price times students. And R of X. All right, what would be a function to represent that revenue? Because the price is changing and the number of students is changing. It's not going to be constant. It's not 20 and 40. And the next time it was 18 and 50. And then it would be 16 and 60. Okay, how can I come up with a function to represent that? Any ideas? I'll give you a first hint. For price, I'm going to represent that as 20 minus 2x. If I do that, how do I represent students?
40 plus 10x.
40 plus 10x. All right, what actually is x represented? What is actually x represent? It's not students and it's not price. Okay.
The amount of times that she's decreased the price.
Number of times she decreases the price. So the number of times you drop the price. So if x is 1, you dropped it 1 time, $2. X is 2, you dropped it twice. So x is the number of times the price is dropped. Number of times the price is dropped. So for this case, it wouldn't make sense to do 2.1 for x because you can't drop it 2.1 times. It's going to be a whole number. All right, go ahead and FOIL those out. FOIL that out. And then put it in standard form. Okay, so I got 20 times 40, 800, plus 200x, minus 80x, minus 20x squared. And so I'm just going to put this in descending order, negative 20x squared, plus 120x, plus 800. All right, there's our function. It's a parabola. It's got an x squared. Is the parabola going to open up or down? It's going to open down. It's going to be negative. All right, what's the y-intercept for this? Now, I'm just going to draw like a very basic sketch. Not that you have to, but just to kind of give you a visual. What is the y-intercept? What do you get when you plug in 0 for x?
800.
800. So it's going to hit way up here, and here's what it's going to look like. It's going to go up for a little while, then it's going to go down. What do you think we need to find to answer this problem? The vertex. We want to know where the price will be, what price will maximize her revenue. This is the revenue. We want to know this vertex right here. Okay? I'm going to use that h equals negative b over 2a. Okay, I'm not going to do the completing the square. So find Find H equals negative B over 2A. Okay, see what you come up with. Anna Waltz, you let me know what you get for H.
3.
Oh, you already got it. It says 3. Correct. So I get negative 120 over 2 times negative 20. I get 3. All right, plug in 3 and go ahead and into the equation and see what you get. Plug in 3 and tell me what you get. Baby,
I got 1,340.
better check your calculator. You got the same thing, Brandon?
Yeah, I did.
Uh-oh. Matthew,
It's 980.
what did you get?
I wrote 960.
You got 960, we got 960, 980, 1,340.
Oh, no, I know.
980.
We got 980.
I got 9.
I think it's 980. 980. We got to work on our calculator entry. Okay. So it should be 980. All right, answer the question. Answer the question. Matthew.
$14.
Matthew's is $14. That is correct. Now let me go back up to here. The price we represented as 20 minus 2x. X is 3. We do 3 price drops. So we went from 18 to 16 to 14. So that's going to be $14. How many students does that get? I know it wasn't part of the question, but you will have to answer this. How many students will that end up equaling? 980? Please say no. Not 980 students. The students is represented by what? 40 plus 10x. X is 3. You gain 10 students every time you drop the price. What do we end up with? 70. Well, what does a 980 represent?
Is that the amount of revenue?
It's the amount of revenue. That's the maximum revenue she's going to get. If she kept everything the same, she would get $800. For each price drop, she's going to get a little bit more. Once she goes past 3 price drops, her revenue will decrease. It will not be the same. So just real quick, let me show you. 14 times 70, 14 times 70, that's the 980. If she drops it again, the 14 goes to 12, the 70 goes to what? 80. Well, at $12, you're back down to 960. So she's going to lose $20. No sense to keep dropping the price. All right, so make sure you answer the question there. Vertex is what we're looking for. We're trying to maximize. All right, let's get this last one in. So you got, farmer has 1,900 feet of fence with which to fence a rectangular plot of land. The plot lies along a river. There's my river. Okay. Only 3 sides need to be fenced. 1, 2, 3. Estimate the largest area that can be fenced. So we're dealing with area. Area of a rectangle is still length times width. You're going to have to come up with some type of equation. Any ideas? Okay, first hint I'll give you, I would let this width be x. Okay, if that width is x, what do you think that length is going to be?
1900 minus x squared?
Not x squared.
2x.
Minus 2x.
Yeah.
1900 minus 2x. Okay, because all 3 sides, you're using all the fence for 3 sides. You don't have this 4th side. Whatever these 2 add up to, if they're like 50 feet each, you take those away from the 1900 for the rest. All right, I want the maximum area. How do I represent where do I go from here? Okay, where do I go from here, Katie?
Plug it into the arrow equation.
We're gonna plug into there. I'm gonna call this a of x because it's a function, and then L is 1900 minus 2x, and then width is just x. Go ahead and distribute 1900x minus 2x squared, and I'm just gonna reorder that. All right, let's see here. You just pay. You don't need to do this. Negative 2x squared plus 1900x. Okay, when you plug in the table, this is your areas. These are your areas. So if x is 2 feet, you'll get an area of 3792. If x is 3, it goes up. We want the maximum. We want the maximum, which is going to be represented by the vertex because it's a parabola that opens down. What's its y-intercept?
0.
0. Plug in 0, you get back 0. So its y-intercept is 0. So it looks like this. We want to find the vertex. So go ahead and use h equals negative b over 2a. Okay, and find what that is. Jordan, you got it?
475.
475, good. So negative 1900 over 2 times negative 2 is 475. All right, what do I do to answer the question?
Plug in.
Plug in 475. So you can plug in a of 475. That's going to be negative 2 times 475 squared plus 1900 times 475. This is going to be a big number. Brandon, let me know what you get. $451,250. I think we're in feet. We agree. I think that's right. I'm going to ask you one other question. It's not listed. What are the dimensions of the field? What are the dimensions of the field? Okay. Anna.
475 by 950. Oh, wait, no, sorry. I did it wrong.
I don't know if you did it wrong.
475, yeah, no,
By 950, right? The dimensions, this is 475, this x value. What's 2 times 475? I think that's what? 950? And then 1900 minus 950 also gives me 950. We agree with that? So those are your dimensions. You need to be able to at least determine that as well. Now, what do you think 475 times 950 is? It better be. Okay, 451,250. Okay, so hopefully that all meshes together. All right, good deal here. Homework page 327. Those of you who are eligible for the independent study, look through that. If you're interested, let me know tomorrow. Because